Beautiful, good. Okay. So if you remember last time, okay, I did present the division algorithm, okay? You know, again, if you have a polynomial f of x and you're dividing it by a non-zero polynomial, I called it d of x. What you can do is you can find two unique polynomials, q of x and r of x, such that, excuse me, such that f of x over d of x, right, equals q of x plus r of x over d of x. Or you can write it this way, this, you know, they're both equivalent, mostly because d of x is non-zero. And here, excuse me, r of x, okay, that's either the zero polynomial or, you know, the remainder r of x, right? That's either going to be identically zero or the degree of r of x, excuse me, is less than the degree of d of x. Okay, again, this was something I presented last time, so, you know, f of x, d of x, what they're called, you know, that's all down there. Okay. Okay. You know, so again, this is the division algorithm for polynomials. There is one for integers, and I don't know if you've seen that one. You might have seen it, I don't know, but this is for polynomials, though. Okay. So from here, right, you know, we did some examples with long division. This example, if I remember correctly, I don't think we finished it, so I want to finish that now. I want to go through it. I mean, there was a method of polynomial long division. I did send those notes out last time, so you should have that. Now, here, what we're going to do is we're going to divide this polynomial by this one. Okay? We're going to use polynomial long division. Now remember, part of the procedure, what you have to do, right? So this is the dividend, this is the divisor, following the notation here. Okay? If you're missing any terms, you want to use 0 as a placeholder. Excuse me, you want to write 0 times x raised to the power, you know, for the missing terms, kind of like what we did with addition and subtraction. So you're going to put the missing terms in, their coefficient's going to be 0. So for instance, in the dividend here, right, notice there's no x term. What can we do? We're going to put x in here. We're going to put 0 times x. Okay? That's what we're going to do. So we put the x term in here. The coefficient of it is just 0. Here, right, x squared plus 1. Well, we're also missing an x term, right? We put it in. It's just that the coefficient of it is 0. Okay, the coefficient of x is just 0. Now we set it up. Remember how we have this kind of like with long division of numbers, okay? You know, we set it up similar to that. And remember, what you do is you divide leading terms. So you have 2x to the 4, right? The leading term, remember, that's the term with the highest power of x. So we have 2x to the 4th divided by x squared. And what we get is 2x squared, right? You divide coefficients. Here the coefficient is 1. It's not written. Here we have a 2, right? 2 over 1 is 2. And for the exponents, you subtract to get 2 as well. And 2 times x squared, right? That's the quotient. You put that over the like term, which is 3x squared, okay? Just wanted to check. I thought the microphone was off. Okay. So we have 2x squared over the like term, 3x squared. Then, just like in long division of numbers, what you do is you multiply, right? And the product you're going to subtract. So 2x squared times this, the divisor, you get 2x to the 4, 0x cubed. I know you're thinking, why not just eliminate that? You'll see why. We don't eliminate it. 2x squared times 1 is 2x squared. What we're going to do is subtract the product. That's why it's good to have this here to make it makes the subtraction a little bit easier. You know, it's just like when we added and subtracted vertically earlier in this semester, right? You know, we use 0 as placeholders. So we're going to subtract this product. And when we subtract, remember, what do? With this wonderful negative sign, you're going to distribute it, and this becomes addition. See? You know, it changes to addition, and the minus you distribute. Doing that, 2x to the 4s, right? These cancel. Minus x cubed, here we have negative 0x cubed, so you just get minus x cubed, okay? 3x squared minus 2x squared, that's just x squared. The 0x, right, that's the next term. We're going to bring that down, right? We don't bring down the negative 1 yet. This missing term we bring down. Now, you might be thinking, what if we didn't put the 0x in here? I'm going to be honest, I haven't really thought about that, but it's good to have the 0x and to bring that down. Okay, so you want to do that. Okay. I mean, if you brought the minus 1 down as well here, I'm not too sure if that would mess up the answer. I want to say it would, but for now, let's just bring down the 0x. So that's what we have here, okay? Now for this quotient, excuse me, for this difference here, right? We have to keep going. We're going to do the process again. Remember, you stop when the difference has degree less than the degree of the divisor, or when you get 0 here. Okay, so if we do negative x cubed divided by x squared, that's what we're doing here, we get negative x, right? Negative is negative 1, negative 1 over 1, right? So we get negative 1, we just write as negative. If you put negative 1 here, that's fine, in front of the x. And for the exponent of x, we have 3 minus 2, right? You subtract the exponents. So we get negative x. That's going to go above 0x, its like term. Then we multiply, right? And then we're going to subtract the product. Negative x times this whole thing, we have negative x cubed, okay? Minus 0x squared, right? You add the exponents of x. I know there's a 0 here, but let's keep it there, okay? And then you have minus x times 1, that's minus x. Now we subtract, okay? What will happen? Well, again, when you subtract this, you could change this into addition and then distribute the negative. You could subtract directly if you wanted to. I mean, for me personally, I like to change it to addition and distribute the negative. Here, when you distribute this negative, all these negatives become plus. So in other words, we're adding. So we get the negative x cubed plus x cubed, that's gone. X squared plus 0x squared, that's just x squared. 0x plus x is just x. This minus 1, we're going to bring that down here. So now we bring down the negative 1, okay? All right. Now, do we repeat the process? Well, we have to, because the degree of this here is the same as the degree of this. Right? You want this, the degree of this difference, to either be less than the degree of the divisor or 0. Okay? Or 0. Okay, so here, right, what do? Well, we have x squared divided by x squared. That's 1, right? So the 1 we put up here, okay? Oh, excuse me, yeah, here it is. Got confused for a second. I thought I forgot it. Sorry about that. So the 1 goes up here. We have plus 1. And then we're going to multiply and subtract. See, that's what we're doing. Multiply 1 by this. We have x squared plus 0x plus 1. You know, 1 times anything is itself. And we subtract that. And again, you know, just like before, this becomes addition and you distribute the negative. X minus x, Here, when we do that, x squared and minus x squared, that's gone. X and minus 0x, that becomes x. Minus 1 and minus 1 becomes minus 2. Do we stop? Now we stop. The degree of this is 1. The degree of this is 2. We stop. So the quotient is this. And this wonderful thing down here is our remainder. Okay? And that's what we get here, as you can see. Okay, and again, as in the division algorithm, this was our dividend. That's equal to the divisor, the d of x, times the quotient, plus our remainder, right? Again, this is our dividend, and this is our divisor. Okay. And you could also write it like this. Both ways are correct. They're both equivalent to each other. All right, that was fun, I know. Any questions on that? Okay, now let me just say this. With the long division, again, the process I use, I put in these zeros here to compensate for the missing terms. If you don't do that, okay, I'm not 100% sure if you really have to do that with long division, okay? But if you don't do that, you know, you do long division correctly and you get the correct answer, you'll still get full credit with me, okay? You know, it's kind of like when we do, what's it called, the grid method with multiplying polynomials. Some people put zeros in there as well, and you really don't have to. So I'm just saying, if you don't put these zeros in here, but you do long division correctly and get the right answers, you know, that's fine, okay? I mean, this process, I'm guessing, is going to have modifications to it, where you don't have to put these zeros in here, okay? I hope that made sense what I just said. So.